In this video, I'm going to sketch the graph of a function. This is a page from my slideshow. We're going to sketch the graph of f of x equals negative 3x cubed plus 4x squared minus x plus 2. First, I'm going to handle the first derivative questions. So that's the intervals where f is increasing or decreasing, to locate the critical points, and then to classify the critical points as local maximum, local minimum, or neither. Then in a follow-up, I'll do the second derivative information. So to get started, I'm going to copy the problem. Here we go. Oh, let's do this in black. Yes. Okay, sketch the graph. And again, the function is negative 3x cubed plus 4x squared minus x plus 2. I encourage you to try this on your own, to pause the video, and then come back when you have questions and watch me do this. So the first step, of course, is that we need the derivative. Okay, so pause the video for a moment and work out the derivative. Okay, f prime of x is negative 3 times 3x squared plus 4 times 2x minus 1. By now, you may be able to do the derivative and the cleanup in your head for something as simple as a polynomial, but there it is. Okay, negative 9x squared plus 8x minus 1. The next thing we need to do is find critical numbers. Do you remember how to find critical numbers? Right? You set f prime equal to 0 and solve. Okay, so negative 9x squared plus 8x minus 1 equals 0. You should recognize by now that this is a quadratic equation, and it's not going to factor cleanly. I'll just give you that hint right off the bat. Instead, we should use the quadratic formula. So use quadratic formula. And remember that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And be sure that everything that should be under the square root is, and be sure that the fraction bar goes where it should, otherwise you will end up with a mess. Okay, for our equation, a is negative 9, b is 8, and c is negative 1. Okay, putting all of this together, negative 8 plus and minus the square root of 8 squared minus 4 times negative 9 times negative 1. All of that is under the square root, and then the whole thing is under 2 times negative 9. Now we need to simplify this just a little bit at least. For starters, the 8 squared minus 4 times negative 9 times negative 1, well, I have a negative times a negative, so I can do a double negative simplification here. 8 squared is 64, 4 times 9 times 1 is 36, and then if we do the subtraction, that leaves us with 28. So that's everything under the square root evaluates to 28. So I have negative 8 plus or minus the square root of 28 over 2 times negative 9, and well, 2 times negative 9 is negative 18. It is possible to simplify this a little further. You will see that in some of the homework tutorials. I don't require it, and I believe the homework will accept an unsimplified answer, but you do need to have the exact solution in terms of square roots and addition, subtraction, multiplication, and division to enter into the homework system. We should get numerical approximations for these numbers. I'm going to write down the two numbers separately. So negative 8 plus square root of 28 over negative 18, and leave some room there, and negative 8 minus square root of 28 over negative 18, and leave some room there. And now let's go over to the calculator. Okay. To get the fraction template, on this model you hit the alphabet button and then the y equals key to get the little menu there. And now I've got a fraction. So negative 8 plus, and second, and this key to get the square root, 28, and then go down, divided by negative 18. Okay, so there we go. 0.15 and some change. Let me see if I can improve the image a little bit here. That's a kind of clumsy number to keep writing down. I'll write it down on my whiteboard here, but for further use, I'm going to store it in the calculator's memory. So, oops, I wanted to do that to store that as A. So let me show you again what I did. When the command line is like this, it assumes that whatever you want to do it to the answer that was last computed. I hit the store button to get the arrow, and then I have to tell it what memory to store that number in, and I decided I'll use A, so I hit the alphabet button, and then this button, you can see there's a little green A above it. And then I hit enter, and now that number is stored in A. That's our first critical number. For the second critical number, remember you can do this. I hit the up arrow, went back through the history, and now I hit enter, and it retypes what I had typed up above. So now I can use the arrow keys and type a subtraction sign there over the addition. So this will compute the second solution. And since I know I want to store it, I'll go ahead and hit the arrow, hit the store button to get that arrow, and then I'll store this in B. So alphabet, and then this is the key with the B. Okay, so that's 0.7384, and I'll write those two numbers down on my whiteboard. Okay, so let's go back, and there are my two numbers. Now if you'll notice, this one is the least, it's the lesser of the two numbers. So I'm going to use this as, let me write over here, C1, and the other one will be C2. I find it very helpful to make sure that the critical numbers are all lined up from least to greatest. It makes it much easier to do the number line and the table. Now this problem is going to be a little bit of a challenge because these two numbers are not all that far apart. Both of them are between 0 and 1. So we'll have to use a little bit different scale for the number line. Let me make out a number line here, go 0, and I'll make each dot of my grid be a tenth. C1 is 0.15, that's about here. C2 is about 0.73, so that's about here. That gives us 3 intervals because we cut the real line at each of those critical numbers. Remember that the real line keeps going. The domain of a polynomial is the entire real line. We have 3 intervals to test. I'll go over here and set up a table. I want increasing, decreasing information first, so I'll use values of f prime to determine that. We'll alternate between test numbers and critical numbers. So the critical numbers are there, and C2 is over here. In this first interval, I need a test number. Any number in that interval will do. An easy one is to just pick 0. In this interval, I need a test number, and again, any number will do. I'm going to pick 1/2, so 0.5. In this interval, again, I need a test number. Any number will do. How about just plain old 1? And let me move my f prime over here, just so that I have room to write everything clearly. And again, you can see the numbers in the table are consistently increasing. That will help you stay organized. Now I want to plug in these 5 values into f prime, and we'll use that to get increasing, decreasing information. So let's go back to the calculator. I'm going to go to the y equals screen. The way I like to organize this part of the calculation is to type the original function in as y1 and the derivative in as y2. So let me type the original function in as y1. That's negative 3x to the power 3 plus 4x squared minus x plus 2. And again, that's the original function from my slideshow. Now, having done that, I'm not going to use it just yet. I just want it in there because I will use it. I'm going to go to the left, and you see the equal sign is blinking there. I'll hit enter to turn off y1. Then in y2, I'll put the derivative, the first derivative, f prime. And remember, we did that here. So I'll type that in. That's negative 9x squared plus 8x minus 1. And we'll do some calculations with f prime now. We're in the process of filling in this table, that column of the table. So I need to type in these x values. Since I reset this calculator recently, I'm going to just double check here. I did second and then this button to go into the table setup screen. If you go down here to the line that says independent, I'm going to go over and hit enter so that it's set on ask. That will allow me to do this. I'll go into the table screen and now type in the x values that I'm interested in. And again, looking back here, there's my x values of interest. I'm going to type in 0. And then this is why I stored the critical numbers in A and B, because now I can hit the alphabet button and then this button to type the A, and when I hit enter, this number is this first critical number that we got. That's C1. Just to show you what happens, if you only type in a few digits, for example, here's what I'm looking at. F prime of the critical number should be exactly 0. But since I didn't type in the number perfectly, I'm getting that f prime of a number that's almost the critical number is almost 0. So that's good. That's still checking what we needed to check. If I type in a few more digits, you can see that I get this sort of strange looking number. This is a number in scientific notation, negative 3.8144. The little small cap e indicates a power of 10. So this is not negative 3.8. It's negative 3.8 times 10 to the negative 4. So it's actually a very small number. The calculator uses this notation because otherwise it would have to write out a lot of zeros and you wouldn't be able to easily see all of the significant digits. If I wanted to, I could also type in the calculation again. So negative 8 plus square root of 28. That's the numerator. And then I have to divide, and just to show you this, you need parentheses if you're going to do multiplication in the denominator. So that would repeat the calculation that we did before, and you can see that when you do that calculation, the calculator has enough digits that it can calculate that f prime of this number is 0 to enough digits that it'll just write 0. Okay, so the whole business there is just to confirm that yes, this 0.15 number that we found is indeed a critical number. We solved our equation correctly. Okay, so this is good. Then we need to type in these remaining numbers. I will do that rather quickly here. Our test number in the next interval is 0.5. I will do alphabet and then this button to type B to recall the number we stored in B earlier. And again, there you see it in all its digital glory. And finally, 1.0 is our last one. So these x values now typed into the table. The y values, that y2 column, remember, those are values of f prime. So I'm going to copy those into my table. So that one was negative 1. Next one gave 0. The next one gave 0.75. The next one gave 0. And finally, the last one gave negative 2. And again, I'm checking that those are 0. That's good. Now returning to the number line, in this first interval, I'm going to look at this test number and see that f prime is negative. So I'll write a negative sign there. If you like, I've got an x number line and we're putting in sign information about f prime. Then f prime is 0 at the critical number. At the second test number, which is testing this interval, f prime came out to be 0.75, which is positive. Then at this critical number, f prime is 0. And finally, in this last interval, I'll look at this row and this test number, and this value of f prime is negative. That's the negative 2. So I'll write a little negative sign there. Remember that f prime gives us information about where f is increasing and decreasing. So let me interpret these signs. In the first interval, f prime is negative. So what is f doing? F is decreasing. In the second interval, f prime is positive. So what is f doing? F is increasing. In the third interval, f prime is negative. So what is f doing? F is decreasing. We can now use the first derivative test to say something about this critical point. There's a critical point at x equals c1. The function decreases, hits the critical point, and then increases again. So that means it is a local minimum. So I'll draw a little minimum right there to remind me of that. For the second critical number, the function f increases, hits the critical point, and then decreases again. That means that this critical point is a local maximum. Let's write out over here what we found. This first number tells us information about an interval. So f is, and we're going to write about this interval. First, it's decreasing. We figured that much out. So f is decreasing on the interval. Okay, now we have to figure out what interval to write. This first interval goes from all the way to the left up to that first critical number. In particular, it goes right past the test number. All the way to the left, that means we should write negative infinity. And then up to the first critical number means that what I should write here is negative 8 plus square root of 28 over negative 18. You could also write it in simplified form, but the homework will ask for an exact formula. It won't let you enter a decimal. Next, I'm going to handle the central interval. In that interval, we found that f is increasing on the interval. Now here's a hint. The central interval picks up right where the left interval left off, and it goes all the way to the next critical number. So this interval starts at negative 8 plus square root of 28 over negative 18. And it continues to the other critical number, which is negative 8 minus square root of 28 over negative 18. So that's the second interval. In the third interval, f is decreasing. F is decreasing on the interval. And again, this interval picks up where the other one left off. Negative 8 minus square root 28 over negative 18. It picks up here where the other one left off, and it goes all the way to infinity. So those are intervals where f is increasing and decreasing, and in the software, you'll be asked to type these intervals into one box, and you'll type this interval in another box. Next, we need to write down the local maximum and minimum points. So first, we found a local minimum at C1. So f has a local minimum at, I'm going to do this as a decimal approximation. It's just very hard to get the exact formula for the y coordinate. So I'll use the critical number there as the x-coordinate. Now, how do you get the y-coordinate? Well, remember, the critical point that we're looking for, this local minimum, is a point on the graph of f. This is a point on the graph of f. So to get the y-coordinate, plug the x-coordinate into the original function f. In particular, none of these numbers are the y-coordinate that we're looking for. Okay, so now we got to pause for a minute. This is why I entered the original function in as y1, because we're going to need it at this point. So I'm going to go over here and turn y1 back on, and now go back to the table. Now here's what we're looking for. That is the 0.15 number. That is our C1, our first critical number. You can see y2 is 0. That's correct. That's the fact that f prime at the critical number here is 0. This is the y-coordinate that we want. That's 1.9299. So let me write that in. 1.9299. And there's the local minimum. The local maximum was over at the other critical point. So we'll write this, f has a local maximum at, again, the critical number is the x-coordinate. And again, I'll do this in decimal form. And again, this is a point on the graph of f. So to get the y-coordinate, plug the x-coordinate into the original function f. So once again, none of these numbers is what we're looking for. If I go back to my calculator, there's C2, 0.7384. There's the y-coordinate. So that is 2.2347. Okay, so that gives us the local maximum and the local minimum, the intervals where f is increasing and decreasing, and that is the information that you can get from f prime. Now again, there's a lot here. You have to stay organized. So I very strongly encourage you to be very neat with these, top to bottom, left to right, label everything and leave yourself notes. I'm going to pause here and pick up with the second derivative stuff in the next video.